Okay, dealing with 7-3 binomial radical expressions. Basically trying to understand how you can add, subtract, multiply, and divide with radicals. I wanted to start you off by looking at something as simple as this, 2x plus 5x. Now, we know that those are like terms, and when you add them together, you get 7x. I'm sure all of you would say that. But if I asked you to add 5x squared and 2x together, I'm sure most of you would say, hey, those are different terms. Those are not like terms. So they are already simplified because you can't do anything more with that. Now we get to an example 1. We have 5 times the cube root of x minus 3 times the cube root of x. Well, those are like radicals. They both have cube roots of x. And so I can subtract the coefficients and say that if you have 5 of them and you take away 3 of them, you're left with 2 cube roots of x. Well, then we get to something like this, where you see radical 2 and radical 3. Those are not like radicals. So this is already simplified. You can't do anything more with that. And when you look at example 3 here, at first you think that this is already simplified because they look like they're not like radicals to me. But trapped inside each one of those square root symbols is a perfect square. So you need to simplify the pieces in order to find out if you even have like radicals. It may be that you do have like radicals. So for instance, 18 has a 9 trapped inside with 2 left over. 8 has a 4 trapped inside with 2 left over. 72 has a 36 trapped inside with a 2 left over. Now, we know the square root of 9 is 3 times 6 makes 18 square root 2. That'd be square root of 9 times 6. Square root of 4 is 2 times 4 is 8 square root 2. And lastly, square root 6, or square root 36 is 6 times 3 is 18 square root 2. So we really did have like radicals. You'll notice that all of them are radical 2. It's very convenient that the first one and the last one do cancel out. So 8 radical 2 is your answer. But you would simply add them, like 18 plus 8 is 26. 26 minus 18 takes you back to 8. It just so happens that those two canceled out. Example 4 talks about when can you multiply these two things together. Well, multiplication, not terribly challenging for most of you. I think many of you will get it, whether you use FOIL or you use the box like I do a lot of times. 3 times 2 is 6. 3 times 4 radical 5 is 12 radical 5. 2 times 2 radical 5 is 4 radical 5. And lastly, 4 radical 5 times 2 radical 5. Well, you got the 4 and the 2, right? That's 8. Radical 5 times radical 5 is just 5. So that's 8 times 5, or 40. 8 times 5, which is 40. Add your like terms together. We have 46, right? Because those are like terms. And our radical 5s, we have 16 of those radical 5s. So there's your final answer on that particular question. 46 plus 16 radical 5. Do not simply distribute the 2. That is the wrong idea here, folks. It is radical 2 minus radical 3 times radical 2 minus radical 3. Anything times itself is what we call squaring something. Once again, I'd be doing the exact same thing. I want you to notice something different, though, on this one. Radical 2 minus radical 3. The radical 2's are going to cancel out. Radical 2 times radical 2. We know that's the square root of 4, but that's just 2. We know that we have, if you take minus radical 3 times radical 2, that's minus radical 6. And radical 2 times, that's minus radical 6. Those are like terms. Lastly, negative radical 3, that is a positive 3. I know it's the square root of 9, but we know the square root of 9 is 3. Look, I have like terms, so I have 5, and these are also like terms, minus 2 radical 6s. Now, when you see conjugates being multiplied together, yes, you should all recognize those are conjugates, irrational conjugates. Something special happens, which you probably should already realize. If you don't, then you'll see it happen right here. 2 times 2 is 4. We have 2 times negative radical 3. Negative 2 radical 3. We have 2 times radical 3. 2 times radical 3. Oh, look, they cancel out. Then we have negative radical 3, positive radical 3. That makes negative 3. I do realize that's negative square root 9, but we all know that the square root of 9 is 3. So you still have that 1 minus sign. So what do we get when we multiply these together? We get the number 1. Okay. The last example that you need to work on here is in example 6. This is rationalizing the denominator, but because it's a binomial in the denominator, it looks a little bit different. Now, it does involve conjugates. If I want to get rid of all the radicals in the bottom, I must multiply the bottom by the conjugate of the denominator. But if you multiply a fraction in the denominator by something, you must also do the same thing to the top, so that the overall fraction that you're multiplying by, anything over itself, is 1. Now, how am I going to do this? Same thing I did before. Now, I'm hoping that you realize for the conjugates, those two are going to cancel out. So it's fairly a waste of time for me to actually fill those in, unless I just like to see radical 5 and negative radical 5. But really, I'm going to get a 1, right? 1 times 1 is 1. And 5 times negative radical 5 is negative 5. So overall, when I get done, I'm going to have negative 4 in the bottom. Now we're going to do the same thing with this. Right? I've got 3 and I've got radical 5. 1 times 3 is 3. I've got a 3 radical 5. This time my radicals aren't going to be canceling out. They are going to be like terms, however. Radical 5 times radical 5 is just 5. So those are like terms. 3 and 5 make 8. And radical 5 and 3 radical 5 make 4 radical 5. Now, that was a pretty bad square root symbol. Now, we need to simplify that, right? We realize we can take a 4 out of the top, leaving us 2 plus radical 5 all over negative 4. You're going to notice that the 4's cancel out. Now, that does leave me with a minus 1 in the bottom, so this is really minus 2 minus radical 5. In other words, that minus really came to the top and changed the sign of everything in the numerator. Be careful for something like that. Now, it really looks like I didn't give myself a whole lot of room on this next question, so I'm going to bump it down a little bit and just try it over again. Okay? So I find the conjugate of the denominator only, and then copy it to the top. And then go through the process of multiplying it, right? I got 6 radical 15. Down here I've got 4 minus radical 15. 4 times 4 makes 16. 4 radical 15. Negative 4 radical 15. Oh yeah, look, I wasted my time. I shouldn't even have thought of that. I knew they were going to cancel out in the bottom because those are conjugates. But I have minus 15 from these two, right? Because a negative times a positive is a negative, and the radicals cancel. So I end up with positive 1. Positive 1 in the bottom there, right? When I add those two things together. Here I end up with, I got a 24, and a 6 radical 15, and a 4 radical 15, and just 15 itself. These two combine together to give me 39. These two combine together to give me 10 radical 15. You're dividing by 1, so it's not going to change any signs at all.